This is my Tesla coil setup. It's got a MOSFET switching a DC current through an inductor, and when the circuit is opened, it's using those inductive spikes to excite the primary. So that's what's called a disruptive discharge excitation. It's sort of like a spark gap, which is a capacitor discharge. This is like a coil discharge, but it's a voltage spike, long story short. And so I've got here just some pieces of foil hanging from tape, and next to that's an old school GE argon bulb. It's just as the top load to the Tesla coil. The white fine wire is the secondary, the copper tubing is the primary. And then here's my variable capacitance for tuning the primary coil into resonance to resonate at the same frequency as the secondary. And so you can see like an electrostatic attraction from the bulb when the coil is powered up, and the foil is drawn to the bulb because the foil acts like a virtual ground. The bulb, each half cycle, whether positive or negative, is very high potential, and so the electrostatic attraction draws the foil to the bulb. But then something I've not noticed before is an interaction when the two foil pieces both touch and spark. It's like they come together and then go back apart based on the charge. And so you'll hear some clicking, and that's just the power supply. As I dial the voltage up and down, it has a relay that goes off and on. So as I power the coil up, the bulb glows bright purple from the argon. So that's how you can kind of see the power level. What we're looking at is the RF power capacitively coupled to the pieces of foil from the bulb, and from one piece of foil to the next. And then as the two pieces of foil are not touching, they're at a separate charge because one's closer than the other, so they're at different potentials. And then as soon as they touch, the electrostatic attraction that had existed when they were at unlike charges goes away because they're now equal charges, and so they touch and they fall back apart, and then suddenly they're at separate potentials again, so they come back together again, and that's the oscillation.